a reality TV show.
It's just zooms on the meatball and it's just abusive. It's abusive.
Okay, you had a question? Quiet. You had a question? Yes, Jessica. 6B says, we want to find the cosine of 2A. So Jessica, with these problems, I recommend you write down the formula that you're going to use. So the formula I'm going to use, actually, this is the one that I have a choice on. So when in a problem like this, I just normally go with the basic formula. This is the standard version. The other two are kind of offshoots of that. So that's the formula I'm going to use. Then I'm going to draw a picture of the given information. It tells me in the problem that I'm in quadrant 3 and that the tangent is 3/4. It tells me that in the problem. So I put the negatives in because I'm in quadrant 3. I do the Pythagorean theorem and that works out to be 5. Now I just take the numbers I need from the picture and plug them in. So what's the cosine in this picture? Yep, so I have -4/5 squared. What's the sine in this picture? And I square that. So I have 16/25 minus 9/25. So the answer is 7/25. That's all there is to it.
We can do a different way, can't we? Right?
You mean using a different identity?
Yeah.
Yeah, because you got, this is the one you got choices on. So you could do 2 cosine squared minus 1 or 1 minus 2 sine squared. They'll give you the same answer. Okay? Delaney?
When there's a problem that says use your calculator, do you solve everything first?
Where what are you
on
talking about?
3A.
3A.
I started by putting it into the calculator and then that didn't work. So.
Okay, here's when I say calculator is allowed, here's what happens. What kind of equation is that? It's quadratic. So you know you're supposed to set it equal to 0, and you know you're supposed to factor quadratic formula or something. So if we just do that, factor it. Would you agree that's okay? Here's the problem. When I solve this, I get tangent equals 4 and tangent equals -1. Now, this is okay. I can handle this one. I know the tangent's negative in quadrants 2 and 4 because that's where x and y have opposite signs. This is 1, so I know this angle is 45 degrees. So that one I can do without a calculator. This is why I need a calculator, Delaney, because when I try to draw this one, it looks like this. And what do I not know? I have no way of knowing that angle, so I need my calculator to find that angle.
What about the one that we did yesterday in class when we put it in?
That's solved graphically. It says literally in the direction solved graphically, yeah. This one, I just have to allow you to use a calculator because that angle is not special. So we'll second tangent to find that angle. But you still would have this answer too. You would still have to take that second answer out. Maren? Got 2 pre-tests, Maren. That's what you need to know. Okay?
For this problem, we're supposed to put it in radians. So for the one with the calculator, should we just change the degrees of the radians and so on? Or
Just put your calculator in radian mode.
and then just plug in the second tangent.
Yep. Yep, and then it'll come out at 1.4 or something. It comes out in decimal.
And then add that to the pi.
Yep, to pi.
So back to that one, I did 1 minus 2 sine being squared. Do you square the sine or whatever? Do you just multiply it by 2?
So sine squared would be 9/25.
Yeah. Do you just multiply that by 2?
So 1 minus 18/25 is 7/25.
Okay.
Same answer. All right, anybody else have a question about? You paying attention, Ms. Clyde?
Yes.
Okay. Anybody else have a question about the pretest? Anything else about the pretest? Delaney?
On number 1, why don't you multiply everything by x and y?
Because if I look at all the pieces of the problem, the common denominator is just x. If you look at the 4 pieces of the problem, this one, this one, this one, and this one, and you think of all of those as fractions, what's the common denominator of all those fractions? Just x. I want to clear my denominators. I don't have a y in the denominator. Now, would it hurt to multiply it by it? No, but you're just going to have to cancel it out then because it'll just be extra. Katie?
You do 2A.
2A. What did you do first?
Well, I thought I was going to turn cosine into 1 over secant.
Oh,
I don't know if
okay.
that was...
That's a good thought. And we don't normally do that. That is not normal procedure, but in this case it makes sense because here's a secant already, and you want to end up with secant. So that's a good strategy in this problem. Okay, so then what?
multiply everything by secant.
Yeah, it's just like this then. Yeah, we're going to multiply everything by secant.
And then I lost.
No. So then we have on top, we have secant b plus secant squared over 1 plus secant.
Yes.
Okay, that is way more than you want to end up with, which means something has to cancel. And I've said it a million times. The only way you can cancel is if you can factor. We have to factor first. Okay, is there any factoring that can happen in there? We can take out a secant on the top, and what will we be left with if we take out a secant?
1 plus...
And what's such good news about that now?
What was the way you would do it? What would be the way you would do it?
Well, now I'm going to do it that way because that's awesome. But I always change everything into sines and cosines. So I would have changed that secant into 1 over cosine. I would have then multiplied by cosine. I would have factored and canceled. And instead of being left with secant, I would have been left with 1 over cosine, which is secant. But I like your strategy. It's good. Okay. Anybody else on pretest number 2? Anna, 2B, what did you do first with 2B, Anna? All right, Anna, listen to this logic. Anna's logic is she's doing 2B, and the okay, wait a minute. You said you changed this into sine? What did you do with that? Okay, you're going to tell me how you did that. So Anna says all this mess is supposed to come out to be 1. So that means I got to get rid of a bunch of stuff. So she said I'm going to make everything cosine, or everything sine. She's going to change everything into sines. So this would become 1 minus sine squared. That's this right here. And then what am I going to do with cosine to the 4th? Please do not think that cosine to the 4th is 1 minus sine to the 4th. That is not right. That's not on your sheet, is it? If you're going to change sines into cosines and cosines into sines, they have to be squared. Period. That's it. That's your only option. They're squared. Cosine to the 4th is cosine squared squared. Would you agree with that? So if you think about it as cosine squared squared, then you can think about it as, I'm gonna go ahead and distribute this right here that I had. All right, now I'm working on this. That will be 1 minus sine squared, which is then a FOIL problem. That's a FOIL. So I've got my sine squared plus my sine squared minus sine to the 4. Now I'm going to FOIL this. So 1 minus 2 sine squared plus sine to the 4. If you can always change even powers of sines and cosines into each other, but you have to do it in terms of the squares. So now when I collect like terms, what happens? The sine to the 4ths are gone. There's a sine squared minus 2 sine squared, and all that's left is 1. So Anna, that is a great idea. Your logic was very, very good. I probably would have changed this one and this one into 1 minus cosine squared myself, because then I wouldn't have had to hassle with the 4th power. So it would have worked that way too, maybe a little bit shorter. But your thought was good. Idea was very good. So if we ran into, let's say, a sine to the 6th, and we wanted to change it into a cosine, we would have to think of this sine to the 6th as what? Sine squared cubed, and then it would be 1 minus cosine squared cubed, and that would be a giant FOIL situation, if you had reason to change one into the other. Okay? Anybody else? All right, pass your pre-test there. I want to check those real quick. And this time, gang, if the only ones you have done are the ones I did in class, please don't hand it in. Just don't hand it in.
Girls gotta stick together.
All right, now what I'm going to do is I'm going to put some problems on the board, and you are going to come up and do them.
Were you at the diversity assembly today?
I don't think
Last night, they had,
Diversity assembly.
what's that thing called? February 12th. Market dinner. Oh man, so shit. I was in the library, and it's just like a whole lot of I was just like, let's see what's going on. Yes.
Okay, so I'm going to put 2 PTQs up here on the board. And I want a couple of volunteers to come up and work them. And I want the rest of you doing them at your seats or on one of the other boards. But if you, I want them done here for sure, and if you're up here, you're on video. That's mine. The other 2 boards, you can do those 2 if you want. Here are your problems.
We'll squat up on one. You wanna go do it? It takes 2 boys.
Yeah.
Sisters gotta stick together. Let's just ponder it for a minute. Come on.
Okay, I need somebody to do the second one up here,
If I
please.
can make this.
Okay, who brought
Trying to make it on board.
I'm sorry. I've never.
Yeah.
Well, I don't know why I raised that.
Oh, he's trash the problem. You gotta start over. You gotta go back.
Wait, what?
Don't go.
Let's go. Let's put it on the board here.
You do the 45s all
Oh, that's
No. Keep doing it. What? You want to do it? The 45. Make your own down here. I'll make mine right here. Oh, sorry.
Everybody should be working on these now.
Give me a break. Serious.
You got that cosine on that? Oh, it's the same. Okay.
What is the old It's the only size that's it's what is the longest
Let's finish that bad boy off. Is that how you want it for?
I get a lot of stuff done.
thing is I
What I need.
Alright, let's see how we did. Did you guys at your seats remember that you could take 105 and break it down into, well, they use 60 and 45. That's a good choice. There are lots of other options. Everybody remember that's what you needed to do? Then you have your formula, which they have memorized, but you will have a formula sheet on the test. Cosine, or sine, cosine, plus cosine, sine. Here are their pictures. The nice thing about using 60 and 45 is you don't have to worry about any negatives, right? So they didn't have to mess with that. They just plugged it in and they got the right answer. Any issues or questions about that? All right, this kind of problem, two things before we get started. Here's one of them. Draw a picture. That means quadrant 3. That means -5 and 13. Perfect. Did the Pythagorean theorem, -12. Perfect. The formula is 2 sine cosine. So they actually,
That should be an X.
yeah. So we have 2, oh there it is, I guess. 2 times the sine, they looked at their picture, their cosine, they multiplied and got the correct answer. Anybody have a question about that? Melanie?
On the first question, could you do a subtraction instead of addition?
Yeah, as long as it subtracts to 105.
Oh, yeah.
Yeah.
Okay.
Yeah.
What was the equation for the second one? After you,
2 sine cosine.
how they get, so the final answer is 2?
No, 120 over 169.
It was 2 times.
Because they had to take 2 times 12/15 times 5/15.
Okay.
Okay, all right, let's have two more, different volunteers.
There's always room for Jesus and assistance.
You may use a calculator on this problem. And
My teacher in math. Put it in my rap test. I'm like, how I'm gonna make this money if pop in like a whole club.
And this one is no calculator. So this one is a calculator. Okay? So here we go. Where are my volunteers? If I have to call on you, you are not a volunteer.
Katie. Women are just mutants. Yeah, it's well lubricated in there.
Okay, no volunteers?
Come on, squad.
Let's not be wimps now.
I can volunteer again, Mrs. Ford.
All right, I'll take it, Mr. Hardy. Thank you.
Yeah, I'm coming back up.
Have all of it there.
See,
I'm not doing both. We're doing one.
fifth period participation was off the charts, Mrs. Ford. I'm disappointed.
Wait, you're doing the other one?
No. You need to calculate this.
He's in the one
Alright, wait.
Switch.
No. I know these.
Take somebody with you if you want to.
I actually knew earlier you said no, you're coming up.
Throw it down. Stay back there. I don't really think we have this before. You're defending him. I will. Today's is college. And I feel like I said the same thing with Ben. It's like triple this stage up.
And you got that. Gotta be in the circle.
Okay, everybody should have a good attendance on both of these problems, especially the first one. We've done a lot of these.
I don't know. Where are we getting this?
That's this one.
That is not equal. Hold on. That's like, it needs to add up to what you.
It needs to add up to one. You have to do one.
No, it's gonna multiply this and then
X on
What?
Hey, this is a calculator. You can't just.
No, we can factor it, but I just like I can't.
Ask Melvardis there.
Which is.
Take a sign of that. Minus one, minus one.
No doubt. Okay, we're back. Now we equal this to 0. So it's add. That's 2x. That's 1.
And then you do the formula.
And do 0.
Yeah.
Now we got calculator. Press it. Can you use your calculator?
Right? They're on there.
Go to graph. Go into
No. Let's look at this one for a minute here, and let's make sure we're straight on something. First of all, getting it set equal to 0, I need your attention, GTQ. getting it set equal to 0 is a good idea, great idea. However, this move is illegal as heck. We cannot factor out part of a sine 2x. What do we do when we see a sine 2x?
The equation.
What?
The equation.
Yep, our formula. That's what we do. So if we want to break out that 2x, but the only way to break it up is to use the formula. There's no other way to break it up. So what is sine 2x?
2 sine x cosine.
2 sine cosine. Yep. Now we'll do what you were doing. Now we'll factor. We can pull out a sine x. And then we'll set them equal to 0. Now this one, tell me about this one. Sine equals 0. Where do I look? I look around my circle, right? And what am I looking for as I look around my circle? Places where,
The sine is 0.
well, yes, and sine is y. So where is y 0? Here and here? So in radians, that would be 0 and pi, right? Now, where does the cosine equal a half? Well, that's going to be triangles. Where will I put those triangles? 1, 4, because cosine is x, and it's positive in 1 and 4, so if that's a 1, that's a 2, that's a root 3. How big is my angle? In degrees, it would be 60, which is a third of 180. So what are my two answers? Pi over 3 and 5 pi over 3, which you got by taking 2 pi minus pi over 3. Okay, so let's make sure we all got the big message. What is the big message we're taking away from this problem? If you are dealing with a 2x, sine, cosine, tangent, 2x, what do you have to do with it first? The formula. Then proceed with factoring or whatever it is you're going to do after that. Okay? Strife and Spawn, you got it?
Yeah.
Okay. Now, how did you guys do over here?
Very well.
So you started out by factoring it,
Yes.
and that looks good. And so you got tan equal 1/2 and tan equal 1.
Yes.
Now both of those were positive, so you drew both pictures in quadrants 1 and 3.
Yes.
This, I presume, read or. We type on our calculator second tangent 1/2. That's how we get an angle. Anytime we get an angle, we type in second tangent or second whatever the function is. So you got 26.57. Then you added 180 to it. You got 206.57. Okay. Over here, I don't know, you didn't need a calculator, maybe you used one, didn't matter, you could. So second tangent 1, you got 45 in both quadrants. That looks good. Woo! Looks good. So any question about either one of those before we put a couple more up here? Okay. All right, let's try 2 more. So if I have any volunteers, it would be absolutely wonderful. If not, we'll let Harvey come back up. is approved.
You can't.
And this is a simplified. Alright, so here we go. We got a prove and a simplified.
Yeah, I'll go off with you.
Cosine x plus cosine 270 sine x sine 270. Is that what it is? When you're like,
Yeah, you really let it down.
you already
You're not
know.
on the whole squat.
Makes me jump here pretty well.
Okay, I need a volunteer. Somebody simplify this one for me, Katie Klein, since all you've done all period is chat. You and Annabelle come up here and get this problem done.
You know what
Actually, I believe you and Katie can do this together. And we gotta get it done in 4 minutes.
Psychology. I think it's this. Ready? Ready? I don't know if it's right. Tell me if it's right.
That's what I got to do.
Is it correct?
Good work, Reed.
You guys done? Yes.
Sine is y over all, so it's negative, and then cosine is x over 6.
He's on the chair, he's coming up like this.
It's like that with 0, 1.
Is she making an X, Y coordinate thing?
No, ours always puts 2, and then it's just x and y back.
Nothing. So it's just cosine X times, what's the cosine 270?
I know, it's
It's right here. That's right. That's zero.
You need to show them your work about.
Which way is it?
There's a 50 cosine 270. Remember, sine is y, cosine is sine is y.
0. You pass the group round.
Which side? Which side?
There you go. Okay, we did a good job in a very short period of time. Okay, the boys, remember that when we have this kind of situation, it's easier to start on the side with the plus or the minus. They changed into sines and cosines, got a common denominator, ended up with 1 over cosine sine, which is the same as 1 over cosine times 1 over sine, which is their secant cosecant. The girls drew 270, used their formula, plugged in 0 for the cosine, -1 for the sine. Now, do you see how I just made up problems? I used my pretest as kind of a guide, but I just made up problems and solved them out. That's what you're doing for your homework. You don't have to make them up though, because I want you to be able to check them with answers. So pick problems out of the book to redo, pick problems off the worksheets to redo. But do not turn in another pretest, a whole pretest or a whole worksheet. Pick and choose what you need to practice. So, Katie Klein, I would say you need to practice a couple more of these. So you'll go back to the worksheets and you'll pick a couple off there.
What is
No, because Annabelle won't be able to help us.
When it's 0 and the 1 you confused. It's not a real triangle, it's fake.
You're right, just remember, cosine is x, and sine is y. Period. Yeah. Yeah. Haven't you told me that earlier? So,
Dude, are we making?
everybody clear on the assignment?
Another appearance in the real.
Okay.
That's a
Okay.
very, very, like the battery or whatever. Last time, like,